Okay, want to go to the section in your homework. You'll see it labeled 717377. It's all lumped together in your homework. When you go to that, you'll see how it's labeled in your homework. It's as part of one homework assignment. Part 1 video. And this is, we want to talk in this section on radicals. Now, you've heard me use the word radical in here before, but let me talk to you just a second about something we've already talked about. If I ask you what is the square root of 25, that's 5. Now, when you see square root of 25, this symbol right here is called the radical symbol. So it's the thing that looks like this. That's your radical symbol. Now, every radical symbol is made up of two parts. It's made up of a little bitty number that sits right down in here. Now, you say, Mr. Rain, there's no number written there. That's true. I'll talk about that in a second. That little bitty number is what we call the index. And so, now, let's read this again. Read this with me. What do I call this? The what root of 25? The square root. Square means 2. Square root. So the square root of 25. So if there is no index written, it is understood 2. So this is square root. And then there's the number that goes underneath here. The number that goes under here is called the radicand. So let me reiterate this one more time. This is the radical symbol. That is the radicand. And so that's asking for the square root of 25. Square root of 25. Now remember what square root of 25 means. It means what times itself gives you 25, of course, which is 5. Because 5 times 5 is 25. Now there's a difference in, let me do one more. Square root of 9, of course, is 3. There's a difference in saying square root of 9 and square 9. There's a difference. The square root of 9 is written this way. If I say square 9, it's there. So there's a difference in taking the square root of 9 and squaring 9. The square root of 9 is 3, because 3 times 3 is 9. But if you square 9, you get 81. So that word root makes a difference when I say square. Square root of a number. So, let's just do some real obvious ones quickly. So, square root of 81 is 9. Square root of 36 is 6. Square root of 49 is 7. Square root of 100 is 10. These are what I refer to as perfect radicals. Now, once again, because the index doesn't have to always be 2, if I wanted you to get the cube root of 27, and in this course you probably won't see any of these, but right here, when I read this is not 3 times, that 3 is sitting down in here. That's the index. So this is read cube root, not cube root of 27. Now, cube root of 27 means what times itself 3 times would give you 27. Or what is the cube root of 64? That's 4. But what is the square root of 64? That is 8. So you see why that index is so important. If you leave that index off, it's understood 2. So anytime this index is anything other than 2, it must be written in there. Just another one, and I'm probably giving you more than you really need right here. 4 through to 16 would be what times itself 4 times is 16. That's 2. Because 2 times 2 times 2 times 2, 4 times gives you 16. So that's what that index right there means. Now, if there is a negative in front of that radical, it does not affect what you do. This right here is the same as this. So this would be square root of 16 is 4, and then times -1, which is -4. So if there's a negative in front of a radical, it just simply makes your answer negative. So like if I had negative square root of 25, you'd say the square root of 25 is 5, but when you multiply it by that negative out front, it's -5. If I have this, if I have a number in front of the radical like this, 3 square root of 16, that means 3, you don't have to rewrite it this way. That's 3 times the square root of 16. And square root of 16 is 4. And then 3 times 4 gives you 12. So if there's a number in front of that radical and there's no sign that's separated, you just do the radical part first and then multiply it by whatever's out front. All right. Now, let me talk to you about something that is probably new to you, and it's this. Square root of -16. If you use your calculator and you know how to punch this in, and you punch in square root of -16, your calculator will give you an error on this. And the reason is this. Think about it for just a second. Can you get the square root of any negative number? In other words, let me ask it this way. Can you take something times itself twice? It's got to be itself now, and ever get a negative? No. Because if you put it down twice, a positive and a positive is a positive, and if a negative and a negative is also a positive. So the square root of a negative number is not a real number. All right, so this will be the first time you've seen me introduce this to you, or I will assume that it is. All right, before I do this, let me ask you this question. And this is one of the few things that I don't dive off into all of the mathematics behind it. Question, tell me what pi is equal to. Most of you know 3.14. But if I ask you why pi is equal to 3.14, most of you have no clue where the number pi comes from. Now, there's mathematical reasons where the number pi comes from and why it's used so much in the geometrical part of mathematics. But anyway, so there are some things that you factually know that you don't know all of the mathematical reasons why behind it. This is one of those things, for the sake of time, I don't dive off into all of the mathematics behind it. So here's what I want you to do. You'll just simply, I want you to take this down and accept this as a fact. This is a definition. We will define I to be the square root of -1. Define I to be the square root of -1. Now this I is what we call the imaginary number. Now, here's the reason I'm introducing you to this. Is the imaginary number is what equips me to take the square root of a negative number. For instance, if I have this, square root of -16, would you agree with me that this is the same thing as 16 times -1? Negative 16 is the same thing as 16 times negative 1. Now, there's a property in math that says this. The square root of a times b is the square root of a times the square root of b. You can break this up into two parts, provided that a and b are not both negative, which is a point that I'm not going to dive off into. But anyway, so both of these are not negative, so I can break this up into two parts. So if I do that, I get this. Now, square root of 16 just gives me 4. And then the square root of negative 1, by definition, we call I. So, here's what you need to take away from this. And this is all you need to remember. It's simply this. Anytime we have a negative under a square root, anytime we have a negative under a square root, not cube root, a negative under a square root, you will always have an I in your answer. So for instance, this is all you need to take away from that. What's the square root of negative 49? 7I. What's the square root of negative 36? 6I. What's the square root of negative 144? 12I. Now, going back to what I said a while ago. If you have a negative in front of the square root, you're going to have a negative in your answer. But if you have a negative under the square root, you're going to have an I in your answer. We'll do another one. If you have a negative in front of the square root, it makes your answer negative. If you have a negative in front of the square root, under the square root, it gives you an I. And then the square root of 4 is 2. Now, if you will notice, all of these radicals that I've put up here so far have been what I call perfect radicals. So I haven't done one like this yet. Square root of 15 or square root of 30. Haven't talked about that yet. Now, I'm going to leave this alone for right now, but before I do, let me say this. A lot of times students will say, well, there's not a square root of 15. Yes, there is. It's just not a whole number. Now, I'm not ready to talk about that yet, but square root of, if you take your calculator and punch in square root of 15, it's 4 point something, or 3 point something, I'm sorry. The reason I know that, what's the square root of 16? It's 4. So the square root of 15 is a little bit under 4. It's just not a whole number. So there's a lot of square roots that we can get square roots of that are decimals. We don't do those because we don't use our calculator for that. So, but all these that I've worked so far have been what I call perfect radicals. And I'll come back and talk about this in just a second. All right, but before I do that, let's talk about now how to take square roots of letters. So let's do this. Square root of x to the 16th. Now, square root of x to the 16th, and then I'm going to do this one right under here, square root of 16. Let's do this one first. What's the square root of 16? 4. Why? Because if you take 4 times 4, what do you get? You get 16. Now, let's do this. Square root of x to the 16th, which is a completely different problem. Let me show you first of all what it is not. It is not x to the 4th. Here is why. If you take x to the 4th times x to the 4th, and you do that properly, do you get x to the 16th? No, you do not. You get x to the 8th. So, this is not correct. So, let's see what we can do. X to what power? So x to what power times itself would give me x to the 16th. How about x to the 8th and x to the 8th? X to the 8th times x to the 8th. Is that x to the 16th? Yes. So the square root of x to the 16th is x to the 8th. not x to the 4th. So is there a quick way I can do that in my head? Yes. What is this index understood to be right here? The index is understood to be 2. What's this power right here? 16. So what would be an easy way to get that power 8? Just simply divide your index into your power, and that'll give you your answer. So let's do something. So suppose I have this, square root of x to the 10th. What would this be? X to the 5th. Why? Because 2 goes into 10 5 times. Well, let's do another one. Square root of y to the 36. Now be careful. Don't do this one like you would do this one. Square root of 36 is 6, because 6 times 6 is 36. But that's not how you do this one. Square root of y to the 36 will not be y to the 6. It's not correct. It'll be y to the 18th. Where does that come from? Divide the index into the exponent to get that. So just be careful right there. All right? And now, is y to the 18th times y to the 18th y to the 36? It sure is. All right, let's do another one. So what's the square root of m to the 100? It would be m to the 50. 2 goes into 100 50 times. Now, if I said, what is the square root of just 100? That's 10. Do you see the difference? It makes a difference when it's an exponent, when it's just a number. Now, if I have this, if I have square root 36 x to the 16th y to the 50th. Remember we said a while ago, the square root of a times b, you can do those separately. So as long as you're multiplying under here, you can do these one at a time. So what's the square root of 36? It's 6. What's the square root of x to the 16th? Divide 2 into 16, because it's an exponent, is 8. And divide 2 into 50, because it's an exponent, y to the 25th. So you don't do numbers the same way you do exponents. Now, if there had been a negative out here, what would I put over here? I'd have a negative. If there had been a negative under here, I'd put an I on my answer. And that takes care of the negative underneath. Okay, the last thing I want to show you in this section now, and I mentioned it a while ago, is I want to show you how to So what I want to show you to complete this video, let me put back up what I just had in case you missed it. Check my video just blinked again. So here's this problem. I did square root of 36, which is 6. Then 2 goes into 16, 8. 2 goes into 50, 25. If there's a negative under here, you're going to have an I. And if there's a negative out front, you put the negative out front there. Okay, what I want to do to close out this section is I want to show you without a calculator, because we don't want decimal answers to these problems. Not one single radical will the computer accept a decimal answer. So what do we do to these problems that it's not a whole number? See, square root of 20, that's not a whole number. Square root of 30, that's not a whole number. Now, they both have decimal answers. But what I want to do is I want to show you how to rewrite these without a calculator, how you reduce these. Now, it turns out that this one will reduce. This one will not reduce. So what we're going to talk about in the next video is we're going to talk about how do we reduce these square roots that are not whole numbers. And that will take us to our section, what was it? 7.1, 7.3, 7.7 video, part 2. Okay, so that will conclude this video.